Hello everyone, this is Mrs. Eisenman. I'm going to take you through the Unit 7 study guide. There's a lot to get through, so we're going to get started right away. The first two questions ask us to simplify the radicals. So you know when we simplify a radical, we need to find the largest perfect square factor that can get pulled out from the number under the radical to be turned into a whole number. Okay, so as you can see here, I typed y equals 80 divided by x into my y equals in my calculator, and I came up with a table of values. You can see here that what we're doing is looking in the y column for the largest perfect square. And I found that right here at 16, and so I broke up square root 80 into square root 16, square root 5, and then over 2. That, of course, is going to simplify to 4 square root 5 over 2, because the square root of 16 is 4. And now these numbers can divide and give us 2 square root 5. So 2 square root 5 is our final answer. Okay, for our second example, we have negative 5 times the square root of 108. So we're going to do the same thing and simplify the radical 108. This time I'm going to go a little faster. Hopefully you've already done the work, so you're just checking your answers. Okay, so I have negative 5, and then I found that the largest perfect square that divides into 108 is 36, and it goes in 3 times. And so that's negative 5. The square root of 36 is 6, square root 3. These two first numbers are multiplying, so negative 5 times 6 is negative 30, square root 3 is your final answer. Okay, number 3, we're looking at the graphs of quadratic functions. So number 3 is asking us to state the roots of the quadratic. Remember, the roots found on a graph are the x-intercepts. So it's where the graph crosses the x-axis, which we can clearly see happens here and here. And those are the x values of negative 1 and positive 3. So those are our answers for that first part. The next question gives students a little bit more difficulty. It says, over which interval is the function decreasing? So this is the way I like to look at it. I say, where is the graph going down? And so clearly that would be all of this. Okay, and then it stops going down right there at the vertex or the turning point. So then what we do is we want to bring that to the x-axis. When it's asking over what interval, these are the interval of x values, okay? So I want to bring that up to the x-axis, and I can see that that would happen all of these x values. All right, so the red line shows where it was decreasing. And then what I want to do is bring that, like I said, bring all those values down to the x-axis. And you can see that it was all of these values, for all of these x's, my red line was going down. Okay? And so I basically need now an interval to describe what I just highlighted in green. And that would be, well, all of these values, so negative infinity up until the x value of the turning point was 1. So negative infinity to 1 is the interval when the function is decreasing. Okay, number 4 should be very quick and easy. It's just asking for the solutions to the system. Solutions are, of course, the points of intersection. So we're just looking for where our two graphs cross and naming the points. So this one here would be negative 2, negative 3 would be this coordinate here. So negative 2, negative 3. And 1, 2, 1, 2, 3, 4, 5. So positive 2, positive 5. Remember, points are always x comma y, and we always need to put parentheses around the x and y coordinates. Number 5 is a word problem that says an Olympic diver is competing for a medal. His height in feet above the water can be modeled by the function f of x equals negative 3x squared plus 6x plus 24, where x is time in seconds, and after he begins the dive. Graph the function, then find how long it takes the diver to reach the water. So in order to graph this function, I need to get a table of values from my calculator. Okay? If we look at our x values that we're asked to graph it over, these are pretty nice ones. If you look here, you can see that they're counting on the x-axis by ones. And so we shouldn't have to do anything crazy in our table of values. We should be able to count by ones on the x, and then they already have the scale on the x and y axis. So it's just a matter of copying down the table and plotting the points. Okay, so when I did this problem, I went ahead and took a picture of my work, and this is what your answer should look like. Okay, here's my table of values. I typed in my equation into my y equals and came up with a table of values. Like I said, counting by ones, I was able to see the repeats and get a very nice set of values that I could plot. And that gave me a good, plenty of points to plot and to have a good picture of what this looks like. Okay, so I plotted those points. I connected them with a nice smooth curve, and my parabola is graphed, and I would get full credit for that. Okay, including a table of values is always a good idea. And then, of course, they ask the question, how long it takes the diver to reach the water. So you can see that this is the height above water. So when the diver is here, that is when they reach the water, and so that would be at a time of 4 seconds. Okay, moving on to number 6. Does the function g of x equals x squared plus 8x minus 6 have a maximum or a minimum? So these questions should be super easy to answer. All we're doing is looking at that first term, that x squared term, and deciding if it's positive or negative. If it is positive, remember that your parabola will be smiling, and so because it is smiling, you will then have a lowest point, a minimum. And so that's really all that one is getting at. Okay, now at what value of x does this minimum or maximum occur? So at what value does the minimum occur? Well, for that, I think the easiest thing to do is to find it in your table of values. Remember, your minimum is the same as your turning point or your vertex. And that happens when you find the repeats on either side. Okay, so when I typed this into my y equals and got a table of values, I went ahead and looked at my table of values, and I'm looking for my y values to repeat. And I know I made this really small, but hopefully you can see here that here I have these y values repeating, which tells me that this point right here in the middle is my turning point or my vertex. So at what value of x does the minimum occur? X equals -4. It's the x value of that turning point. Okay, number 7. Write the equation in vertex form for a quadratic with a turning point of -7, -11. Okay, so remember the vertex form of a parabola is written like this. Y is equal to x minus h squared plus k, where hk is the vertex. So h comma k is your vertex. So if my vertex here is -7, -11, I don't know what Mrs. Hennessy says, but I always say switch the sign, keep the sign. So the number that goes in the parenthesis, we switch the sign. So if it's -7, when we put it in the parenthesis, it's going to be x plus 7 squared. And then the y value, we keep the sign, so -11. And if you're not sure, if you're not confident that that's right, just go ahead and type this into your y equals. Type this equation in your y equals and look at it and see if that is in fact the vertex. Now you might have to adjust the window a little bit because of course these numbers are a little bit bigger, but you could always go to your table of values as well and see, verify that it is a vertex. Okay, number 8. Which equation has the same solution as 3x squared minus 8x plus 4 equals 0? So there is a couple different ways that you can approach and answer this question. Because this is multiple choice, I'm going to give you a strategy that I think would be the easiest. Basically, it's saying which of these factored forms is the same as this equation right here. So we know it will have the same solutions when it crosses the x-axis at the same place. So if I type this first equation into y equals, okay, so type y equals 3x squared minus 8x plus 4 into my calculator and graph it, and then I type each of these into y equals, and I see which parabola matches up one on top of the other. So when you do that, okay, the first one actually right away matches up right on top. Okay, so if you look at this, this is what I mean. I typed in y equals 3x squared minus 8x plus 4 into my y1, and then I typed in 3x minus 2, x minus 2 into my y2. Just choice one. Now when I hit graph, only one parabola came up. And so what that means is that they were both the same, okay? They landed right on top of each other, meaning that they have the same solutions. Okay, number 9, write the equation in standard form, then solve by factoring. Standard form, of course, means that everything is brought over and set equal to 0. All right, so I need to move everything to one side. So I'm going to go ahead and subtract my 4x squared and add my 12x. Remember, I do the opposite, and then I line them up right underneath the like terms. So these things are going to cancel out, and I get 0 on the right, which is what I wanted. On the left-hand side, I'm going to have x squared. Negative x plus 12x would be plus 11x, and then my plus 18. Okay, so now I'm solving this by factoring. So that means I should be able to, this is a simple trinomial, go right to 2 sets of parentheses. So x and x, my signs are both plus signs. 2 numbers that multiply to 18 and add to 11. So if I look in my table of values, if I need to get the factors of 18, I should come up with 9 and 2. 9 and 2 add up to 11, and they multiply to 18. So now I do my t-chart. X plus 9 equals 0. So x is equal to negative 9. X plus 2 equals 0. X is equal to negative 2. So my two solutions are negative 9 and negative 2. Okay, number 10 is asking us to solve using inverse operations. So in order to do that, we have to get the thing that's squared by itself. So a couple quick steps. Okay, so taking a look at what I did, I first added the 47 to both sides. Always remove the addition or subtraction first by doing the opposite. Then I divided both sides by 3, leaving my x plus 2 squared by itself equal to 49. Okay, at this point I'm ready to take the square root of both sides. We do this because the inverse operation to squaring something is taking its square root. So the squaring and the square root cancel each other out, leaving just x plus 2 on the left. On the right-hand side, when we take the square root within an equation, it is critical to remember that we get two answers, plus and negative. Square root of 49 is 7. Now we're going to go ahead and isolate that x. We bring the 2 over by subtracting it to both sides. So negative 2 plus or minus 7. This gives us two rational answers that we need to go ahead and split. We get x equals negative 2 plus 7, which of course is 5. And we get x equals negative 2 minus 7, which is negative 9. Okay, number 9 is another method that we learned for solving quadratic equations, completing the square. So the first step is to get it into the x squared plus bx equals c form. So that means I have to move my 23 over, so I'm going to have x squared minus 8x equals 23. Next, we need to determine what half of b squared is. So of course my b value is the number in front of my x, and I want to go ahead and take half of that, so negative 8 divided by 2, and then square it. So when I put that in my calculator, I get 16. 16 then needs to be added to both sides of my equation to balance it out. So plus 16 here and here. X squared minus 8x plus 16 is equal to 39. What that did was made a perfect square trinomial on the left-hand side, so that now I can factor that into two identical binomials. X and x, my signs will both be minus, and what times what is multiplies to 16 and adds to 8, 4 and 4. Because they are identical, I can write it as x minus 4 squared equals 39. And now I'm ready to do what I did on the last question. I need to undo that squared, so I take the square root. And again, when I do that, I need my plus and minus square root 39. This time 39 is not a perfect square, so I just leave it under the radical. I'm going to go ahead and move the 4 over. So I'm going to bring it over here, x equals 4 plus or minus the square root of 39. Now, at this point, my question asked me to round to the nearest hundredth. So I do not need to simplify the radical. I don't this one isn't even possible, but if it was, remember, you don't have to simplify the radical if they say round to the nearest hundredth. You can just go right ahead to your two branches. Okay, we have the positive branch and the negative. So when I type them into my calculator, 4 plus the square root of 39, rounded to the nearest hundredth, should be 10.24. And 4 minus the square root of 39 to the nearest hundredth is negative 2.24. So those are my two answers. Okay, the next question asks us to use the quadratic formula. We've talked about this one a lot in class. This is the most popular method used to solve for the roots of a quadratic equation. So once again, if I'm solving for the roots, I do want to write it as an equation set equal to 0. So equals 0 to start. Now if I'm using the quadratic formula like it asks, I want to name my A, my B, and my C. So A here is the number in front of x squared, 4. B is the number in front of x, also a 4. And C is my constant, negative 9. Okay, now I'm ready to go and plug it into the formula, which I've already written for you over here. Okay, so I go ahead and I say x is equal to, instead of thinking of that as negative b, we like to think of that as the opposite of b. If my b is positive 4, the opposite is negative 4, plus or minus the square root of. Remember, everything that you plug in should be put in parentheses. So parentheses, b is 4 squared minus 4 times your c is negative 9. All over 2 times a is 4. So x is equal to negative 4 plus or minus. All right, at this point we want to type in what's under the radical into our calculator. So when I type in 4 squared minus 4 times negative 9, exactly as I see it, using all those parentheses, I will get 160 over 8. Okay? These directions are a little different than the last ones. They do say to solve in simplest radical form, which means that square root 160, I need to try to simplify it. And this is just like what we did on the first two questions of this review packet. We have to simplify that radical. We have to find the largest perfect square that divides into 160. So I went ahead and found it already, and it is square root 16, and it goes in 10 times. Okay? That will then simplify to plus or minus 4 square root 10 over 8. And now in my class we call this the magic triangle. If I find a whole number triangle, meaning all the corners of the triangle are whole numbers, and I can divide the same number out of all of them, I'm going to go ahead and do that. So hopefully you can see that I can divide them all by 4. So I'm going to divide every one of those numbers by 4, leaving me with negative 1 plus or minus 1 square root 10 over 2. That is my final answer in simplest radical form. Okay, number 13 is a pretty straightforward, easy one. It's just asking you how many zeros the quadratic function has. Now, of course, another word for zeros are roots or solutions. We know that we can look at the graph of a quadratic and see visually how many solutions it has by looking at how many times it crosses the x-axis. So what I did was I went ahead and graphed this parabola and just made a sketch of it in my I graphed it in my calculator, made a sketch of it, and I can clearly see that it never crosses the x-axis. So I would say that it has no real zeros. And my justification is the graph does not cross the x-axis. All right, easy done. Okay, number 14, we have a rectangle area word problem. It says, your friend wants to sell jars of homemade spaghetti sauce. He thinks it will be cost effective to grow some of the ingredients in his backyard. He sets up a garden for tomatoes and wants to use the additional space to grow basil. The area of the tomatoes will equal 75% of the area of the entire garden. Okay, that last sentence is so important, okay? And we're going to go ahead and make sure that we use that and unpack that to understand how to write our equation. Write an equation that could be used to determine the value of x. So I am going to literally unpack that sentence I just underlined, okay? I want to make sure that I clearly understand it. It says the area of the tomatoes will equal, so I'm going to put my equal sign, 75%. How do I represent 75% in mathematics? I use a decimal. I move the decimal over 2 places, so 0.75. 75%, the area of the entire garden. So 75% of the area of the whole garden. Okay, so I can right off the bat tell you the area of the tomatoes. And the reason I can do that is it is this space right here that is 9 by 5. So I can tell you that that is 45 because 9 times 5 is 45. Okay, so that is equal to 0.75 times the area of the whole garden. All right, so now we have to figure out what is the length and the width of the whole garden. Well, we can see here that our length, this blue line down here, okay, is going to be 9 plus, we're going to add on this distance from here to here, which is x. So our length is going to be 9 plus x. Times our width, well, now go the other way here. I would start and I would have up until 5 and then again add on the x. So 5 plus x is our width. So we have area of the whole garden would be length times width, 9 plus x times 5 plus x. And 0.75 is representing 75% of that. So that's an equation that can be used to now find x, which is what we added on, which is of course where the basal is going to go. All right, the next part of this says explain how your equation models the situation. Okay, so I wrote an explanation. There's a lot of different answers that would get you full credit. I basically just kind of broke down my equation. You can read what I wrote, and hopefully you have something similar to that. Really, you just need to talk about all the different components of your equation. Where the 45, the 0.75, and of course where your 9 plus x and 5 plus x come from. Okay, the last 2 questions are review of past topics. The first one is on functions. It says that Jane describes this given relation as a function. Is she correct? So of course, when you are verifying if a set of ordered pairs is a function, all you're doing is looking at the x values and basically asking, do they repeat? And so yes, she is correct. No x values repeat. Okay, the next one is a literal equation, the last question here. Literal equations have multiple variables and you are asked to solve for one of them. So in this case, we have b equals mxy. So the question I always have my students ask is, what is the operation that's going on between the variables and which one do I need to get by itself? So in this case, b is equal to mxy. M, x, and y are all multiplying. When variables are bumped up against each other without any plus, minus, or division, that is multiplication. I here need to get y by itself, so that means I need to undo the m and the x away from it, so I need to divide them away. And I have to do that, of course, to both sides. So very quickly, b divided by mx equals y, and that is my answer. Okay, ladies and gentlemen, I hope that this video helped you go over the study guide for Unit 7. Please, please, please make sure that you spend some time studying through your notes, looking over your quiz, looking over any other old homework assignments, the in-class study guide that we did, or practice test that we did, and just really make sure that you're ready. We want to see some really good high scores on this test. Thanks and have a great night.